Hi, I'm Bob. Welcome back to the tutorial on solving the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will continue addressing the problems related to market structure and externalities and allocating property rights to reduce externalities. Here's exercise 4.1. Suppose that the only way to reduce pollution from paper production is to reduce output. The government imposes a tax on the monopoly producer that is equal to the marginal harm from the pollution, so that the tax may raise welfare. If the untaxed monopoly originally produces more than the social optimum, a tax may cause welfare to increase. As the supply and demand diagram shows, the intersection of the social marginal cost curve and the demand curve determines the social optimum, ES, and the socially optimal output, QS. The before-tax monopoly equilibrium, EM, is determined by the intersection of the monopoly's private marginal cost curve, MCP, and the marginal benefit curve, MR. The monopoly output is QM. It is higher than the socially optimal quantity, QS. Because the monopoly produces more than the social optimum, it creates a deadweight loss of the blue triangle area. In this case, if the government imposes a tax equal to the marginal cost of the negative externality on the monopoly producer, it will force the monopoly to internalize the externality, and its after-tax marginal cost curve will coincide with the social cost curve. The intersection of the marginal revenue curve, MR, and the social marginal cost curve, MCS, determines the after-tax monopoly equilibrium of ET, where the after-tax monopoly produces an output of QT. The tax causes the monopoly quantity to fall from QM to QT. The after-tax output QT is less than the socially optimal output QS, leading to a deadweight loss of the red triangle area. The after-tax deadweight loss is smaller than the before-tax deadweight loss, implying that the tax raises social welfare in this case. Let's tackle exercise 4.2. In the following, use the model in exercise 3.8. For part A, what is the unregulated monopoly equilibrium? For a linear inverse demand function, we can directly write the firm's marginal revenue function. The unregulated monopoly equilibrium, EM, is determined by the intersection of the firm's marginal cost curve, MCP, and the marginal revenue curve, MR. We obtain the monopoly quantity, 40. Substituting it into the inverse demand function gives the monopoly price of 160. For part B, how could you optimally regulate the monopoly? What is the resulting socially optimal equilibrium? We first find the social optimum. which is determined by the social marginal cost curve MCS and the demand curve. The social marginal cost equals the private marginal cost plus the externality marginal cost. We obtain the socially optimal quantity of 40 and the socially optimal price of 160. Second, we find the regulation that forces the monopoly to produce the socially optimal amount. Because the monopoly output QM equals the socially optimal output QS, the government does not need to do anything to regulate the monopoly producer. The social optimum is a quantity of 40 and a price of 160. Let's jump to section Allocating property rights to reduce externalities. Here is exercise 5.1. List 3 specific examples where Coasean bargaining may result in the social optimum. I use the examples in the textbook. We consider 2 adjacent firms, an auto body shop and a tea house. As the table shows, the noise from the auto body shop hurts the tea house's business. The total profit of the 2 firms represents the social benefit. So the social optimum is achieved when the joint profit is maximized. Without clear property rights, the noise drives the tea house out of business. So the joint profit is 400, which is not a social optimum. The first case is assigning a clearly defined property right to the tea house. The tea house is granted the right to silence. Without bargaining, the auto shop should shut down, and the joint profit will be $400, which is not socially optimum. However, according to the Coase theorem, a socially optimal solution can be achieved if the property rights are clearly defined and the 2 parties can bargain at a low cost. They should be able to reach an agreement whereby the auto shop pays the tea house between $200 and $300 for the right to work on 1 car. As a result, the total profit will be $500, which is the social optimum. The second case assigns a clearly defined property right to the auto body shop. The auto shop has the right to make noise. The tea house may have to shut down. However, if the bargaining cost is negligible, then the 2 parties can reach an agreement. The tea house can pay the auto shop between $100 and $200 so that the auto shop works on only 1 car, and the tea house makes a profit of $200, leading to a joint profit of $500. It is a social optimum. Note that the social optimum is $500 in the above 2 cases. But how the 2 parties split the joint profit depends on who has the property right. In the first case, the tea house is given the right to silence, so its profit is no less than $400. In the second case, the property right is given to the opto shop. The tea house profit is no higher than $100. Another example in the textbook is to buy the town when the right to be free from pollution is given to the residents in a small town. The firm responsible for the pollution internalized the externalities by buying the right to pollution from the small town's residents. The residents moved to other places without pollution. It could be a socially optimal solution because the joint profit is maximized. The textbook gives 3 reasons for the failure of bargaining. First, transaction costs are prohibitive. If there were many residents in the town, the firm in our third example may be unable to gather them and negotiate successfully. Second, firms may engage in strategic bargaining behavior. Suppose the opto body shop insists on working on 2 cars. A social optimum cannot be achieved. Third, information about the costs and benefits of the externalities is unknown. Without the information, it is difficult to bargain. Let's answer exercise 5.2. Analyze the following statement. Is garbage a positive or negative externality? Why is a market solution practical here? Since the turn of the 20th century, hog farmers in New Jersey fed Philadelphia garbage to their pigs. Philadelphia saved $3 million a year and reduced its garbage mound by allowing New Jersey farmers to pick up leftover food scraps for their porcine recyclers. The city paid $1.9 million to the New Jersey pig farmers for picking up the waste each year, which was about $79 a ton. Otherwise, the city would have had to pay $125 a ton for curbside recycling of the same food waste. It is a win-win situation. Garbage is a negative externality for Philadelphia City, but a positive externality for New Jersey hog farmers. Philadelphia saves money by giving garbage to pig farmers and paying a low fee than the alternative way to deal with food waste. New Jersey farmers receive their pigs' food for free, and the money the Philadelphia government pays them. It illustrates the importance of a market for externalities. It facilitates exchanges between the 2 parties. Without the market, Philadelphia City has to pay $125 per ton for recycling the garbage, and New Jersey farmers may have to pay for the pig food. With the market for garbage, the farmers receive money for pig food. And the Philadelphia government saves money too. The social optimum is achieved in this way. Let's solve exercise 5.3. Austin is going on holiday with his infant daughter and has a first-class air ticket. He values being in first class instead of coach at $300. A CEO has the seat adjacent to him and is considering offering to pay Austin to move to one of the empty seats in coach. For Part A, the CEO values quiet at $600. Can Austin and the CEO reach a mutually agreeable price for Austin to move to coach? Yes, if they can bargain and the CEO offers between $300 and $600 to Austin, they can reach an agreement that Austin moves to coach. For Part B, if instead the CEO values quiet at $200, can Austin and the CEO reach a mutually agreeable price for Austin to move to coach? No, the highest price the CEO offers is $200, but Austin values being in first class instead of coach at $300. They cannot reach an agreement. For Part C, assuming efficient bargaining, for what range of the CEO's value of quiet will Austin move to coach? Because Austin values the seat at $300, the CEO has to offer Austin more than $300. That is, the CEO values quiet at more than $300. Thank you so much for watching this video and solving the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.